So this is the 29th session on rigid body kinematics. This is also in continuation of the 28th video. So in this also I take up problems on pure rolling from acceleration point of view. Okay. So you go through these numericals properly. If you understand them, you don't have to go to anywhere else. You don't have to refer to any other book. Okay. You don't have to go to any costly coaching institute. Okay. So you go through them. And if you have any difficulty in understanding topics, you write down your difficulty in the comment box. I'll answer them through that. Okay, fine. So I'll write down the question. In the diagram shown below, all the details are given. In the diagram shown below, all the details are given. I draw the diagram. There is a thin circular drum with center at C and radius R. This is the horizontal ground surface, fixed surface. Here, this undergoes pure rolling. At the instant under consideration, acceleration of center C with respect to ground is a rightward. Here it undergoes pure rolling over this fixed surface. Omega is the angular velocity of drum with respect to ground at the given instant. Beta is the angular acceleration of drum with respect to ground at the given instant. Okay. P1 is the material point of drum in contact with the ground at this instant. P2 is the highest material point of drum. P3 is the material point on the circumference of drum at the same horizontal level as center C. This angle theta. So all these quantities A, omega, beta are with respect to ground. Okay. What is the first thing which you have to find? First thing which you have to find is find the value of A by R beta. Find the relation between A, R and beta. Find the relationship between A, R and beta. Okay. Now to find the relation between A, R and beta, what do? We apply SRC procedure for acceleration to this drum between the points C and P1 in ground frame. So SRC procedure for acceleration to the drum between C and P1 in ground frame. Now for that, what we do first, we decide the selected point which is C, other point OP which is P1 sorry. I draw the line joining OP and SP and OP which is simply this line, C and P1. I give the acceleration of C to P1. I give the acceleration of A to P1. Now write down the sentence. Omega and beta are both clockwise. Omega is clockwise. P1 moves in a clockwise circle with center at C and radius R. Two accelerations have to be given to P1. Omega square R upward direction, R beta rightward direction. Now along the surface, unit vector along tangent is ET hat. Along upward normal, unit vector along normal is EN hat. Acceleration of P1 with respect to ground is the vector sum of these three terms. A P1G, G meaning ground frame, that is just equal to A minus R beta into ET hat plus omega square R into EN hat. This is a P1G. Now here G1 is the material point of ground in contact with point P1 of the drum. Here pure rolling is taking place. Now we know from the criteria of pure rolling, that the component of accelerations of 2 points of two bodies in contact along common tangent plane, the contact point are equal. Now with respect to ground, acceleration of G1 is 0 because G1 is the material point of ground. So as seen from ground, acceleration of G1 is 0. So acceleration of G1 in common tangent plane is also 0. And acceleration of pure rolling criteria, acceleration of P1 in common tangent plane, that should be equal to that of G1. But acceleration of P1 in tangent plane is a minus r beta, and that is same as the component of acceleration of G1 along tangent plane, which is simply 0. So a is equal to r beta. First relation has been fully proved. Okay, fine. So one thing I have fully found out. Alright. Now I will rub this one. Now second part B is this. Second part of question is this. Find the accelerations of the material points. So before going ahead, one thing we should note. So how much do we get the acceleration of P1 in ground frame? Along ET the components cancel, only along En remains. So this becomes omega square by r En hat. So acceleration of this point P1 of the drum is towards center. This is a result of vital significance. When I make videos on rigid body kinematics, then you will see that this has far-reaching implications. Okay, so you just remember it. I'm just mentioning it here. It will be used when I make up videos on rigid body kinematics. This will be used very much. Okay. Now I take the second part of the question. Second part of the question is, find the acceleration of the points P2, P3 and P4 with respect to ground in IJK notation. Find A P2G, A P3G and A P4G. G meaning ground. In I hat J hat notation. In I hat J hat notation, where the coordinate system is as shown here. X axis rightward, y axis downward. Okay. Now we determine the acceleration of P2 with respect to ground. Okay. I determine the acceleration of point P2 with respect to ground. So we apply SRC procedure for acceleration between C and P2 in ground frame. SRC procedure, acceleration to drum in ground frame between C and P1. So SP arrow C, OP arrow P1. Sorry, C and P2. Sorry, P1 already we have used. Okay. I draw the line joining SP and OP. That is simply line CP2. I give the acceleration of selected point C to P2. A. Now we write down the sentence. Omega is clockwise. So P2 moves in a clockwise circle with center at C and radius R. So two accelerations have to be given to P2. Omega square R to C and R beta along rightward direction. So acceleration of P2 with respect to ground is simply the vector sum of these three terms. So A P2G becomes A plus R beta along x axis. And omega square R in downward direction, that is along y axis. This is the required answer. But we know that A and R beta are equal, so we can remove R beta from this. R beta is equal to A. So here also it becomes A. A plus A becomes 2A. 2a I hat omega square a j hat. This is therefore the required answer. Fine. So a p2g becomes 2a I hat plus omega square r j hat. Alright, fine. Now I find the acceleration of p3 and p4. Okay. So this I'll rub it, okay? I'll not, okay, I'll rub it. Now, to find AP3G, so SRC process of acceleration to drum in ground frame between the point C and P3. Okay, so here instead of P2 it becomes P3. Now again I draw the line joining SP and OP, that is the line CP3, which is horizontal at the given instant. This distance is R. I give the acceleration of C to P3, which is simply A. Then I write down the sentence, omega is clockwise. P3 moves in a clockwise circle with center at C and radius R. So I give two accelerations to P3. Omega square R towards center C and R beta along downward direction. Now acceleration of P3 with respect to ground is the vector sum of these three terms. So A P3G is equal to A minus omega square R into I hat, because that is along, and R beta in downward direction, that is along y axis, that is R beta into j hat. But you know that R beta is just equal to A. So this becomes equal to this, I drawn the line. A minus omega square R into I hat, and this becomes A into j hat. This is therefore the required answer. This is the acceleration of P3 with respect to ground, okay? So acceleration of P3 with respect to ground becomes this much. A minus omega square R I hat plus AJ hat. This is the acceleration of point P3. Now we have to determine the acceleration of point P4 with respect to ground. Okay. This I'll rub it now, okay. Now we find the acceleration of P4 with respect to ground. AP4G. For that we apply SRC process of acceleration to the drum between the point C and P4 in ground frame. Okay. So SP arrow P4. Sorry, no, C. OP arrow P4. Okay. I draw the line joining SP and OP. So this is C, this is P4. Now I take the actions. I give the acceleration of selected point C to other point P4. That is the rightward. Now write down the sentence. Omega is clockwise. P4 moves in a clockwise circle with center at C and radius R. So two accelerations have to be given to P4. Omega square R to P4 towards center C. And one R beta at right angles to CP4. This one. This is simply A. By geometry, this angle also with theta. Now acceleration of P4 is the vector sum of this, this and this. So acceleration of P4 in ground frame becomes AI hat plus this one, R beta cos theta plus R beta sin theta j hat, dissolving into components. And omega square, this is theta. Omega square cos theta j hat. And omega square sin theta minus I hat. Minus I hat, okay? This is AP4G. Now what I will do, I will replace R beta by A from pure rolling criteria. And I collect the coefficients of I and J separately. So this R beta is replaced by how much? A. This R beta is also replaced by how much? A. I hat and I hat. So I hat becomes common. A plus A cos theta minus omega square R sin theta into what? I hat. And J here and here J. r beta becomes a from pure rolling criteria. So it becomes a sine theta plus omega square cos theta into what? J hat. This is therefore the required answer. Alright. So acceleration of P4 with respect to ground is a plus a cos theta minus omega square sin theta I hat plus a sin theta plus omega square cos theta into j hat. This is the required answer to the part P4. Okay. This problem I fully discussed. Okay. Now I'll take up one more problem on this in this video. Alright. I love this one. Okay. Now I take up one more problem in this question, in this video. Okay. Problem is this. Problem is this which I write here. A circular drum with center at C and radius R is initially at rest over a fixed horizontal surface. Fixed horizontal surface and begins to undergo pure rolling with a constant clockwise angular acceleration beta at time t seconds later, at time t seconds later, P is a material point on the circumference of the drum at same level as its center. At same level as its center. At this instant, acceleration of P with respect to ground is in vertically downward direction. Downward direction. Question is this: find the angle turned through. Find the angle turned through by this drum with respect to ground in time 0 to t in radians. Okay, fine. This I have it now. I have written the entire question. So at first I draw the diagram of the solution. Diagram of the situation I draw. This is the side view of the drum. C is the geometric center. R is the radius. This is a fixed horizontal surface. At time 0 it is at rest. Now it has a constant clockwise angular acceleration beta. At certain time t seconds later, the drum has advanced ahead because it's undergoing pure rolling over the surface. At this point, center C is here. At time t, this is the material point P of the drum at its circumference and at same horizontal level as its center C. Now it is given that at this instant, acceleration of P with respect to ground is in downward direction. Now we have to find the value of t. Now we have to find in angle turned through by this drum in time 0 to t, small t in radians. So now question is, how do we start to solve this problem? That is the main thing. From where do we start to solve this given question? That is the main problem. Okay. So now how do you start? See, beta is given to be constant. For for a point moving along a straight line with constant acceleration a, we know that displacement d of point in 0 to t is given by what? D equal to ut plus half a t square. Now, analogous to straight line motion, there is a circular motion with constant angular acceleration beta, initial angular velocity omega naught, angle theta turned through by the body in time 0 to t, which rotates with a constant angular acceleration beta with initial angular speed omega naught, is simply omega naught t plus beta t square by 2 from the chapter on kinematics of circular motion of point with constant angular acceleration beta. Now omega naught is the initial angular velocity of the body. Now initially the drum was at rest, so omega naught is 0. And theta is the angle turned through by the drum in time 0 to t seconds. So theta is just equal to beta t square by 2 in radians. So now by some means we have to determine the value of this quantity, that will be the value of theta. Okay. Now at time t, acceleration of point P with respect to ground is in downward direction as it is given in the problem. So you see at time t what I am doing, I am set up a coordinate system here. X axis rightward, y axis downward. Now at time t, center has some acceleration a. It has a clockwise angular acceleration beta. T seconds later, the drum has gained some angular speed omega also. Now omega is what? Omega naught plus beta t. For a body rotating with constant angular acceleration beta, angular velocity omega of the body at time t is given by omega naught plus beta t, where omega naught is the initial angular velocity of body, that is of the drum. But initially drum was at rest, so this omega naught goes away. So omega becomes how much? Omega becomes beta t. So now see, this I'll rub this vertical line, okay, just causing confusion. Okay, fine, alright. So C and P are at same horizontal level, okay. Now what I do, I apply SRC procedure of acceleration to C and P in ground frame, okay. So SRC procedure to between drum in ground frame, G frame, G meaning ground frame, between the points, between the C and P. So SP arrow C, OP arrow P. I draw the line joining C and P, simply this. I give the acceleration of selected point C to other point P, that is A rightward. Now I write down the sentence. P moves in a clockwise, omega is clockwise. So P moves in a clockwise circle with center at C and radius R. So two accelerations have to be given to P. Omega square R towards center C and R beta in downward direction. Now acceleration of P is the vectors of these three terms. Now if you suppose we set up a coordinate system like this, x axis rightward, y axis downward, the acceleration of P with respect to ground becomes A minus R beta into I hat plus R beta into J hat. Sorry, A minus, it's not R beta, sorry. A minus omega square R into I hat plus R beta J hat. But it is given that acceleration of P is in downward direction. That means APG is in along J hat. So component of APG along x axis should be 0. So APG, x component of APG must be 0. So that is A minus omega square R is 0. So this means A is equal to omega square R. And now from pure rolling criteria, A will be equal to how much? R beta, as was discussed in the first question of this video. A equal to R beta, I proved. That result will be used here also. Now omega is what? Beta t, as it determined here, because constant beta, omega not 0. So omega square becomes beta square t square into r. Now r goes away. So from this we see that beta t square is just equal to 1. So angle theta turned through by the drum in time 0 to t seconds is beta t square by 2, that is half radians, is the required answer. Okay, so angle theta turned through by the drum in time 0 to small t seconds is equal to half radians, and that is therefore the required answer. Now half radian approximately, you must know it is around 29 degree. 1 radian comes out to 180 by pi, that is roughly 58 degree. So half radian becomes 29 degree. So required answer is equal to 29 degree. Okay, so 29 degree in radians, it is half radians. Okay, so this also I have discussed. So this was the 29th video on the rigid body kinematics. In the 30th video, I will take some more problems on pure rolling from acceleration point of view. Okay, so these are a bit here. Fine. So this I close it here. Fine.